Hi, it's Mrs. Pound, and I am back with the very last video for the second chapter. We've only had 3 videos. We are speeding right through this chapter on linear motion. So let's keep going as we've already talked about speed, velocity, and acceleration. Today we're going to talk about free fall. So our objectives today are to describe the motion of an object in free fall from rest. Describe the motion of an object thrown straight up until it hits the ground when air resistance is negligible, and determine the speed and distance fallen any time after an object is dropped from rest when air resistance is negligible. So let's get started. Okay, so the first thing we want to talk about is from section 2.5, free fall, how fast something is moving. We have to remember that the only force acting on an object in free fall is gravity. We will learn when we talk about forces that in order to accelerate an object, a force must act on it. In this case, the force is gravity causing objects to accelerate when they are dropped. The most accurate value for acceleration due to gravity is 9.8 meters per second squared, and I'm sure you've heard that value before and have used it before. But in this course, because we're focusing on concepts instead of equations and numbers, we're going to round that off to 10 meters per second. So we will generally use that value in this course because it's just an easier number to work with. And it won't cause our answers to be that much different because we're trying to get the ideas. We don't care that it's an exact answer. The letter customarily used to represent acceleration due to gravity is the lowercase letter g. So you will see that in the equations. Now our equation is velocity equals acceleration due to gravity times time. So v equals g times t. I'm not going to show you any examples. We are going to do some examples in class together, but I'm not going to show you that right now because, again, we're going to do the examples to help us understand the concept better, not so that because we'll be tested on it necessarily. So one thing we are concerned about is when a ball is thrown into the air. So you see the juggler here in the picture. And when he is juggling and throwing the balls into the air, one thing we need to know is that the ball's velocity at the highest point is 0 meters per second. When we throw a ball in the air and it stops at its highest point, it stops momentarily so that its velocity is 0 meters per second. But it is still accelerating because velocity and direction are changing. It stops for a split second to change its direction and starts falling again. So even though it is stopped, it is still accelerating. And its acceleration at that point, even though it's stopped at the top of its path, is still 10 meters per second squared. And we're going to be taking a look at that in class. But some very important points. Let me go back over those here again. The velocity at its highest point is 0 meters per second because it is instantaneously stopped to change its direction and start accelerating again. It is, in fact, still accelerating even though it is stopped because it's changing its direction and its velocity. And its acceleration at that point is, in fact, 10 meters per second squared. Very important to remember. That's why I went over it again. So don't forget it. Okay, so moving on with free fall, we not only want to know how fast the object is moving, like a ball or a skydiver, but we also want to know how far it has moved. So our equation for that is distance equals 1/2 the acceleration times time squared. D equals 1/2 AT squared. Now again, I want you to get the concept here. I'm not going to plug in any numbers. I'm going to verbally say some numbers, but it's more so that we're thinking about what is going on. So I want you to think about this. As a ball falls freely, the distance it falls each second is less, the same, or greater. Let's look at the equation. We're talking about time here. Okay, so let's just pretend that the half and the acceleration don't even exist. We're just looking at time. So at 1 second, 1 squared is 1. At 2 seconds, 2 squared is 4. At 3 seconds, 3 squared is 9. So you see that number getting bigger and bigger and bigger exponentially, really. It's getting bigger and bigger and bigger. So which answer makes sense? As a ball falls freely, the distance it falls each second is less, the same, or greater. If the number is getting bigger and bigger and bigger, the answer must be greater. Okay? So if you just stop and mentally plug in some simple numbers into the equation, you can come up with that answer. So our objectives for these two sections are to describe the motion of an object in free fall from rest, describe the motion of an object thrown straight up until it hits the ground when air resistance is negligible, and to determine the speed and distance fallen any time after an object is dropped from rest when air resistance is negligible. Now, I've started on some of these objectives in the video. We're going to finish these up in class by looking at a couple of problems that we work through together. So for this video, remember your 5 questions in the margin of your worksheet. And this is the conclusion of the chapter. Like I said, we will wrap it up in class.